Okay, so we talked about reference angles. Oops. And I did talk about, I did talk about some of the degree ones because, again, we still have to have the idea here. And remember that I could ask you for a reference angle of any angle. It doesn't matter if it is, oh, I forgot to time. And so I don't forget that the back of the homework we talked about while you were out of the room, you're only doing the radians on the back of the homework. There's radian and degree questions. You're only doing the radians. Okay? So if you need that explained, then just remind me when we're done. But I could give you any angle. I only use the special angles that are actually on the unit circle here, but I could say, what is the reference angle for 170 degrees? Well, 170 degrees would get me to right here, so the reference angle would be 10, right? Like you can still find them. But when we're using the special angles, if the denominator is 3, 4, or 6, then the reference angle is pi thirds, pi fourths, or pi sixths. Those are your only options. Okay, that's it. Or they're quadrantal angles. So when you're thinking about the hand trick, okay, and this is what somebody did too when they came up, because most of the time I can see your wheels turning, but it doesn't always come out of your mouth. But this person was like, all right, 2, 3, 4, 6. And he was like, here, 6. So that's, remember, it goes that way. It's 2, 3, 4, 6 for pi. And what he means by that is pi halves, pi thirds, pi fourths, pi sixths, right? And then 2 pi or 0. But that's how you get to that point. And if those are your special angles. Anything else, you might need to do some subtracting or adding, but you could still figure it out. But don't make these harder than they are, because reference angles are easy and they're necessary for us to figure out what we need to do with it. So then we used them to find the tangent and the cosecant. And we actually, because I skipped the degree ones, I actually skipped like the simpler ones. They're not all this complicated, and we're going to do some more of these on the back. But we think through these same pieces, which we'll look at. And then we talked about the quadrantal angles, where if I said, what quadrant is pi halves in? It's not in a quadrant, so your answer would have to be quadrantal. It's on the positive y-axis. But if I'm not asking you what quadrant it's in, we just need to know for the sign of it, like positive or negative, then I don't even care about that. It's the ordered pair that's going to help me with that. And we'll do some of those examples today. Okay. So let's go ahead and get started on the back, because we didn't do any of this in the back yet, right? Okay. So, and this is a repeat right here. This is a repeat from some notes we had before Christmas, and also when we filled in the rest of that hot pink sheet, which I think we did on Friday. So it says a unit circle is a circle with a radius of 1 unit. That's why it's called a unit circle, right? Because the value of r is 1 for each point on the circle, the trigonometric functions theta of theta are defined as blank. All right, so this is my hypotenuse, which is 1. This value right here would be my x value, because it's how far I go, right? And then this right here would be my y value. So theta is this angle right here. When I go to find the sine of theta, well, sine is opposite over hypotenuse, just like it always has been. So it's going to be y over the radius, but again, because this is the unit circle, the radius is 1, so it's just y over 1. That's why sine of theta is y. It's the y value of the ordered pair that you get. Cosine theta is equal to what? X. It's your x value. Because it's adjacent over hypotenuse, so it'd be x over 1 is just x. Tangent is opposite over adjacent, so it's y over x. And that's why we say tangent is sine over cosine, because it's y over x. You need to understand it both ways, y over x and sine over cosine, that sort of thing. Then cosecant, secant, and cotangent are reciprocal, right? What is cosecant the sine? So this is just going to be 1 over y. It's also 1 over sine theta, but it's 1 over the y value. Secant is the reciprocal of cosine, so it's 1 over x. Cotangent is the reciprocal of tangent, so it's x over y. Notice that there's only, in each pair that are reciprocals of each other, there's only one co, right? Here's a cotangent, a cosine, and a cosecant. And S and C, C and S, like they don't match, so that can hopefully help you keep them straight. All right, so then the coordinate of P can be written as cosine theta, sine theta. And again, those of you in AP Physics, that's your mg sine theta, mg cosine theta. That's where this is coming from. Mg is just the radius, or that's the magnitude of your vector is what it ends up being. And we'll connect all this to vectors eventually too. All right, so then we have what's called the 16-point unit circle, which we've already learned. So it's kind of like this, kind of backing up a little bit because we went a little out of order. But so the unit circle that we know and love, and we absolutely have to know, is frequently used to map pi sixths, pi thirds, or I'm sorry, pi fourths, and pi thirds, which is 30, 45, and 60 degrees. And their multiples, right? Not just pi thirds, but 7 pi thirds and 5 pi thirds, whatever. And their multiples, as well as 0 or 2 pi, pi halves, pi, and 3 pi halves, which are your quadrantal angles. Now, to work these questions that we're going to do down here, we're going to do them the same way we did those first two on the front on Friday. But yes, if you had the unit circle completed, which all the answers aren't on that unit circle there, you could just pull the answers right off the unit circle. Don't do your homework that way, because if you do, you're not going to have a unit circle in front of you when you need it later on, and so it's not going to help you at all. It might help you get the right answer, but it's not going to help you learn how to do it. Using it to check yourself, absolutely. I mean, that is, use it as a tool, not as a crutch, is the important thing here. So we're going to use instead like the hand trick and those things that we know to be able to figure this out. So just like you had to be able to tell me what is the cosine of pi thirds and pi halves and pi sixths at the door, now we're going to do some of these that aren't those exact things. So we're looking at cosine of 3 pi fourths. All right, so the first thing is if it's in sine or cosine, then I'm good with that. But then I have to ask myself a few other things. 3 pi fourths. What quadrant is 3 pi fourths in? Okay, so check this out. If all I really care about right now on here is that this is 0, or really, I don't even care about these right now. So if I'm here at 0, then this would be 4 pi fourths. So I end up here, it's 3 pi fourths. So I'm actually in the second quadrant. So I'm in quadrant 2. This is important. Now the reason I care about that is because that's going to tell me if my final answer is positive or negative. So in the second quadrant, is cosine positive or negative? Positive. What's my little saying to go around here? All students take calculus. And those are the sine, cosine, and tangent, what's positive in that quadrant. So in this quadrant, which means in quadrant 2, cosine is negative. That's what the quadrant gives me, is that my final answer is negative. Then I need the reference angle. What is the reference angle for 3 pi fourths? Don't make it harder than it is. Pi fourths, that's it. Because think of it this way. I'm here, I go around to here, this is 4 pi fourths, I have to back up one, so I'm at 3 pi fourths. That means I'm pi fourths away, just one of them away. If I'm using these special angles, which all of these are, if you're expected to know them, I don't expect you to know what the sine of pi sevenths is. That's not something you know in your head from the unit circle. That's something you need a calculator for. But these that we can get from the unit circle, then your reference angles these are only options: pi fourths, pi thirds, pi sixths. That's it. So then I have to figure out what is the cosine of pi fourths. All right. Well, we use the hand trick. This is pi fourths, right? These are cosine. This is sine. What's the cosine of pi fourths? Square root of 2. Right? So that value is part of my answer, but then I have to take into account that it's negative, so my answer is negative square root of 2 over 2. Because remember, they're just all reflections of each other. The numbers that are in the ordered pair are the same. What changes is the signs, the SIGNs, depending on what quadrant you're in. You see how easy that is? It's not that bad at all. It really isn't. You just got to know your first quadrant. All right, so let's look at this number 18. This is the tangent. So it's not in terms of sine or cosine, so I need to write it that way. Is tangent sine over cosine or cosine over sine? Sine over cosine. It's why I write. Okay, so this is sine theta over cosine theta. Okay, so then I have to ask myself, 2 pi thirds. That's in which quadrant? Second, right? Okay, I heard that was other people were thinking there. Because this would be here to here is 3 pi thirds. So even maybe over here, maybe you need to write, okay, this is 3 pi thirds. It's 4 pi fourths. And this is also 6 pi sixths, right? So what we're thinking about over here is that this is 6 pi thirds, 8 pi fourths, and 12 pi sixths. Do y'all understand what I mean by that? Now, you don't necessarily have to write it out, but that's what you're thinking. Like, that's where I would end up. So since this is 2 pi thirds, well, this would be 3 pi thirds, so 2 pi thirds is up here. So we are in quadrant 2. In quadrant 2, is tangent positive or negative? Negative. And then what is my reference angle? Pi thirds, exactly. Now, on this one, I have to do sine over or sine divided by cosine. I can put it in a fraction and put a fraction in a fraction, and it looks all yucky. But when we do that, we're going to change it to like elementary school division anyway. So I'm just going to start with that. This just basically means sine divided by cosine. You agree with that? So pi thirds. What is the sine of pi thirds? Square root of 3 over 2. So it's square root of 3 over 2 divided by the cosine, which is what? 1/2. Now, when you divide fractions, I know you don't love fractions, but dividing fractions isn't that bad, right? What do? Multiply by the reciprocal. So this is the square root of 3 over 2 times 2 over 1. What happens to the 2's? They cancel out. So that leaves me with the square root of 3 over 1, which is the square root of 3. Should that be positive or negative in the end? Negative. And so it's negative square root of 3. You see how that works? The same pieces every time. What quadrant, what, whatever, and just blah, blah, blah through those things. Okay. Now, cotangent of pi halves, right? Well, it's not in terms of sine and cosine, so I got to do that first. So is cotangent sine over cosine or cosine over sine? Cosine over sine. So this is cosine theta over sine theta. So then our next question is, what quadrant are we in? We're not in a quadrant, right? Because it's a quadrantal angle. In this case, I'm not writing quadrantal, blah, 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 because it's not asking me that. Like, I need to know that, but I don't have to write all that out. What I need from here, since it's a quadrantal angle, is what is the ordered pair at pi halves? What is that ordered pair? 0, 1, right? Super easy, right? So then that means now all I have to do is take that stuff and make my fraction out of it. Of the 0 and 1, what is cosine? 0 or 1? 0. So this becomes 0 over the sine, which is 1. And what's 0 divided by 1? 0. What if it had been 1 over 0? What's that? Error. Except error is not true. Why is it an error? It's undefined. You're not allowed to divide by 0. You never have been. You never will be. Okay? So if 0 is in the denominator, it's undefined. Okay? We all good so far? All right, so let's do 20. Secant. That's not sine or cosine, so I have to put it in terms of that. Secant is the reciprocal of what? Cosine. So this is going to be 1 over cosine theta. Now, I highly suggest you write that stuff down. There'll be people like, well, I just know that in my head. Well, that's great. But once I think that and I go on to think the next thing, I'm going to have to go back and rethink that because I've already lost it, right? So write it down. So then negative pi fourths. What quadrant is that in? It's negative. Fourth. It's negative, so we're going this way pi fourths, so I'm in the fourth quadrant, right? So in the fourth quadrant, is cosine positive or negative? The fourth quadrant is positive, right? So it's positive, which means my final answer is just what? Pi 4, just pi. Always acute, always positive. So it's pi fourths. So that means that pi fourths, well, it's not my answer because I don't have an answer yet. All right, but I have to figure out the cosine, and the cosine of pi fourths. Once I do, I have to have the reciprocal of it, right? So just what is the cosine of pi fourths? Square root of 2 over 2. Do we all agree with that? But I need the reciprocal. Now, I can write it as 1 over square root of 2 over 2, but that's yucky. As long as you know that this means a reciprocal, we just flip the fraction. So instead of the square root of 2 over 2, I'm going to write 2 over the square root of 2. Does that make sense to you? That is the reciprocal. But what is wrong with this answer? Square in the denominator. So I have to rationalize, which gives me 2 square root of 2 over 2. And then what happens with that? It's the square root of 2. Good. And is this supposed to be positive or negative in the end? Positive. It's fine just to do your thing and then just think about the sign at the end. Just don't forget to think about the sign. Okay? Ask me questions if you've got them. What are you confused about? Well, do you have a question, though? Because you might not be the only person thinking it. Where did I lose you? Most of it? Okay, so let's see if, let's do at least, I need you to come up with again. 20 minutes. All right, so tangent, I have to put it in terms of sine and cosine. It's going to look like good, cosine. So sine theta or cosine theta. It's like every other one. I say, all right, 5 pi fourths. What quadrant is that in? Third. 5 fourths. Good with that? We understand how to get there? You understand how to get that? Yes? Okay. So I'm in quadrant 3. In quadrant 3, is tangent positive or negative? Positive. Positive. So it's positive. And then my reference angle is what? Pi fourths. Wait, what? Because tangent is positive, and that's why we care about the quadrant. This is quadrant 3. This means the tangent, every tangent value is positive in quadrant 3. Because my x and y are both negative. And so if I put and tangent is y over x. So if I put negative over negative, I get a positive answer out of it. Okay, does that make sense? All right, so now I've got all this stuff. Pi fourths. So here's pi fourths. So pi fourths is here, and I need the sine and cosine values. What is the sine value of pi fourths? Square root of 2 over 2. Divided by the cosine value, which is square root of 2 over 2. What does that give me in the end? What is anything divided by itself? 1, right? Like if you need to see the math for it, this is the square root of 2 over 2 times 2 over the square root of 2, right? And you see how that just cancels out and you get 1? But anytime you divide something by itself, you're going to get 1. Okay? We okay with that? All right. And that's maybe a case even where the fraction and a fraction might have been better because you could actually see it better. So they just kind of cancel each other out. So you get 1. And is it positive or negative? Positive. And you're done. Do you have a question yet? Now you understand. Okay, that's good. That's why we work more. That's why we work multiple examples, because these all look a little bit different. All right. Number 22, cosecant. That is the reciprocal of what? Sine. It would be nice if it was secant, but it's not. Okay. So 1 over sine theta. So then my next question is, what quadrant? So I'm here. This is 6 pi 6, so 5 pi 6 is here in the third quadrant. Yes? Okay. So I'm in quadrant 3. In quadrant 3, is sine positive or negative? Negative, because it's only tangent that's positive. Then my reference angle is pi 6. Okay. Yes, so tangent, so when I look in quadrant 3, tangent, what's positive is tangent. Sine and cosine. So I've do pi 6, right? This figure here, and I want the sine. What's the sine of pi 6? 1/2, right? But I don't really want sine. I want the reciprocal. What's the reciprocal of 1/2? 2. And then should that be positive or negative in the end? Negative. Okay. Yes. We got it. Ask me a question if you've got it, because you are not going to be the only one that has the question. You're just the only one brave enough to speak up. I'm not going to make you feel stupid, I promise. Okay. Well, you might internalize that. I'm not going to be like, I can't believe you asked that question, you moron. No, I would never say that. But when sometimes, when you ask a question and then somebody answers it, and then it seems real easy and obvious, you just I know I do sometimes like, oh, that was a dumb question. But it's okay. I ask dumb questions all the time. Sometimes all it takes is you asking it. Has that happened to you? Like you ask a question, and before you finish your sentence, it's in your brain. So sometimes it's just you saying it out loud. So you just got to be willing to speak to me. Everybody, we get the hand trick, right? Okay. And the hand trick works for 0 and pi halves as well. But also, you just know what those ordered pairs are. This just maybe an easier way. It works. It just wouldn't make a whole lot of sense. But these 3, this is super important to you. Okay. Any questions at all? Y'all are doing good, huh? How do you do tangent? Is that what you said? Okay. So tangent is sine over cosine. That makes sense? Okay. So once you do that, this part's the same. These next three steps are the same no matter what. Like, what quadrant is that in? This angle in, that is tangent positive or negative, and then what my reference angle is. So what this really is here, and maybe this one's, let me redo 18, because this one's weird because it turns out to be 1. But if I look at, let me just rewrite like 18 down here. So once I did all that, so do you understand all the stuff I have in purple? Like that I'm rewriting it as sine over cosine. It's in quadrant 2, which means it's negative, and what my reference angle is? Okay, so then what we have is sine over cosine, right? So for pi thirds, the sine is the square root of 3 over 2 over the cosine, which is 1/2. But basically I skipped this step. This is your sine over cosine, because first of all, it's yucky and y'all don't like it anyway. Second of all, I wouldn't do anything with it right here. I'd rewrite it anyway, and we didn't have a whole lot of room for it. This just means division, so I just wrote it as division instead of as a big fraction. Does that make sense to you? And then when you divide fractions, you actually multiply by the reciprocal. So that's why I flipped the 2 over 1. And then the 2's cancel out, and I get that number. So once you set it up, it's just a fraction thing, and it just depends on what's, you know, what the numbers are. Does that? Yes. Yes, because like this cosine of theta, the cosine was square root of 2 over 2. So again, I could write it like this. I could write it as 1 over square root of 2 over 2. But first of all, that's yucky. And second of all, I would just rewrite that as 1 divided by the square root of 2 over 2, which means that's 1 times the reciprocal. And since it's 1, that's where I just started right there. So just as long as you know that this means reciprocal, once you find that value, you just write it upside down, and then you fix it if you have to. Okay, does that make sense? Like here, once I wrote it upside down, I didn't have to rationalize anything. Reciprocal is 2. Anything? Ask me questions. Don't tell me tomorrow just because you were afraid to speak up. Good? All right. So go ahead and glue or tape this in. Get started on your assignment. If you feel comfortable with the front, even though most of you haven't touched it, but this is a little weirder to you, then start with the back on the homework while you're sitting in here, okay?